Hey guys, welcome back to the shop. We're going to start on our next project here. We've got these 3 hydraulic cylinders. These are off of a Mahindra tractor, and these 2 cylinders right here, they're identical. These are for manipulating the bucket or the loader on the front of the tractor. And then this guy here is for an outrigger on the tractor. It should be about the same, but it's just, it's sized up just a little bit different as far as length and stroke. Now they could not get the pin out, so they ended up having to cut the pin. So we will have to set this up in a press and see if we can press that pin out of there. So they're just going to simply replace that factory pin. That was the simplest solution. They even tried to use a little bit of heat, but they just couldn't get it to move. So it was absolutely froze up in that eye right there. All right, so we'll set them up in the big reed vise right here. I've got my handy stand here that I brought from the other shop that we'll support it with, and we'll start getting these tore down. I'm hoping that this is going to be a simple reseal job. A lot of the other tractor cylinders I've been doing have been the same way. They have glands that are easily removed with a spanner wrench. So we'll get our open face or adjustable face spanner so that we can get those guys unscrewed, pull everything out, do some inspecting. But because of the way that they feel, like that one's pretty loose right there, I think it's just the seals have gone bad and they just need to be replaced because they were leaking oil. So that's the main, you can see it's just, I put this pig mat underneath it because it's been steadily dripping oil out of there. So rod seals are probably gone. I'm sure the piston seals are about shot. So let's get these things apart and see what we can do with them. Bucket for the oil because we'll have some drip out. All right, so we've got our spanner wrench here that we're going to be using. This is the Martin number 483 with the 5/16 pin there. We'll see how tight these guys are. Use a soft blow and see if we can knock this thing loose. Pretty much all it was to it there. Okay. All right, everything's looking good, just the seals are wore out. Take these over to the smart washer and get everything washed nicely. I don't see any scratches in the barrel, so our barrel's in good shape too. This one anyway. Yeah, that's the one that was real loose right there. All right, same condition. We'll go ahead and get our outrigger cylinder taken apart also. That's pretty loose too. I can tell that it's The rod glands are wore out and the wipers are completely gone. That one's got a lot of dirt buildup around the gland there, so you know it's been pouring oil out of the gland. All right, so that one takes, now that one's got the larger pins. Yeah, let me get the other spanner. So it should be the 484. This one's a Williams, but all the part numbers are the same from all of them. Yep. Let's see. Well, that ain't good. Knocked it out of there. Let me get my bigger soft blow. Ain't good. I'm pulling the hole out of it right there. So this one is obviously proven to be tight. All right, I need a little leverage on that one. Let me see what I can do. All right, I've looked around for like a cheater. Even my big pry bar, it won't quite fit on the end of this wrench right here. So everybody else is closed for the day. I may have to wait and see what I can find at the, maybe the welding shop's got a piece of tubing that, or a pipe that I can fit over this. I just need some leverage and I don't have anything here to fit over it. I'm gonna try wrapping on it a couple more times with this soft blow, but I might have to wait till the morning to try to get this unscrewed. Or we could drill us a hole in the side, which is perfectly fine, and use a pin spanner on the OD. That might work a little bit better. But let me see if I can hit on this a few more times accurately. Just keeps popping out of the hole there. I think I'm gonna hold off because it's not coming and I need to find something that I can put over this so that we can get us some torque on it, some leverage, and hopefully break it off that way with a cheater. I think what I'm gonna try instead is my pin spanner here that will go on the OD of the gland. So I need to drill me a hole. So we'll punch it right about there. I want it so that I can get it in about that position, and I got my big pry bar that I can stick over this handle, and hopefully that'll be our leverage that we need to unscrew this guy. There we go. All right, let's see if we can make that work. Flip that over so that that sharp edge isn't facing me. God almighty. Well, so much for it being easy. See what it just did? Just broke the spanner. So that sucker is tight. All right, we made it down to the home shop. I've got a few more tools down here at my disposal to help me get this stuff done. We've got the cylinder set up. We've got our torch right here behind me, so we're gonna use a little bit of the blue wrench, hopefully to help us get this thing apart. I've got the this chain wrench here that I'm gonna try to use. So my attempt is gonna be to put some heat right in this area here to help swell the tube and hopefully help break its bond to those threads inside there. This is gonna be a really smoky, nasty job because you have rubber up inside here. You have O-ring seals, you have wipers and rod seals. So that's why, you know, we've got the door open. I've got my window open back there to hopefully get a little cross breeze, and we'll get it heated up and see if we can get this thing to break loose. If we can get the gland to loosen up, it should be easier from that point. So let's give it a shot. is where it's helpful to have two people. You see how it stops? It was moving. You get too much heat on there, it starts deforming the aluminum because the aluminum is so soft. So you have to be careful about that, or else you just end up melting the aluminum. So you see what I'm talking about with the smoke. Now it tried to move, but then it stopped. Sometimes you got to keep the growth of the steel with the heat on it in order to get it to move. You move the torch off and it shrinks back right away and you can't move it. But I think I'm digging into the aluminum. I have to get another bite and let it cool down for just a minute. Yeah, so this one is being a bear, doesn't want to come apart. I'm afraid that I've already distorted the gland trying to get this thing to unscrew. I feel like part of what's going on is that we've got so much corrosion in there on the steel barrel. You may have some galling in there on the threads, and when you get two pieces of material that gall together, it's hard to put enough force on it to get something to come apart short of cutting it apart. So I talked to him about this being a Mahindra cylinder. He is going to check with Mahindra and see if this is just a simple replacement cylinder there instead of going any further into what we're doing here. And if this is, if you can just buy this one from Mahindra and replace it, he's going to see if that's the option and, see how much it costs to do that. Because if I can't get this thing to unscrew, the next step is you have to get in there and actually start machining this out, which is a whole nother ball game. To me, it's not worth trying to go through that kind of effort for a cylinder like this if it's a replaceable item, even if it cost you, I really don't even know how much this thing would cost new. I would say somewhere in the neighborhood of $500 to $800. I don't know, that's just a guess. So we're just gonna stop right here. I'm gonna get back on the other two cylinders so that I can get the seals off, get the pistons off, size the seals up and get those things ordered, because those two are just fine. This one right here is wanting to be the aggravation. I'm getting back on the first two loader cylinders. Let's get the piston off. These are going to be fine. I just need to get everything apart so that I can start sizing up the seals. There's your piston. That's your piston seal. This is the wear band. There's going to be an O-ring on the inside. That's what seals the fluid coming through the threads of the piston there. And you can see that right there on the end of the rod. All right, and then here is this is your gland right here, and then this is the main culprit of the issues that's going on. You can clearly see this is where the wiper is. This is what's left of the wiper. It's pretty much deteriorated and gone. The rod seal inside there is completely deteriorated and falling apart. I'll get a closer video of this so you guys can see that in more detail, but this is the main culprit of the problems right here. Same exact thing. Bad rod seal, bad wiper. You also have the O-ring out here on the outside of the gland, and this is to seal moisture from coming into the cylinder and into the threads up inside this area here. And then this is your tube seal right there. This is what seals the hydraulic pressure from coming through the outside of the gland and out the threads. So we get all these seals out and start sizing them up. Wiper is just disintegrating. See, not much left of it. So in these cases, what I do is I clean everything real well, and I get in there and measure out the groove. But I believe, just based off the way the groove looks, I believe this is going to be an ST designated wiper, but we'll know once I get in there and measure it out and see. So let's see if we can get that rod seal out of there as well. All right, so it's a loaded seal. You can see you got the O-ring. That's to apply pressure to the lips to keep the lips like pushed back. And the same thing, it's just falling apart. Sometimes you can get in there like this and pry it out of there. So there you go, that's what's left. There's still a little bit left in there. All right, of course you got your O-ring out here too. Pretty good size O-ring right there. I think that's going to be a 300 series O-ring, and then we got our backup there as well. Backup's going to be fine. I think I'm just going to leave that on there. But then we've got one more O-ring right here that we'll place these as well. These are just to seal the moisture out of the threads. That goes on the outside. All right, there it is. Now we just got to figure out what seal and wiper we need, right? All right, so there's what's left of our seal and wipers. We'll go ahead and get one of the wear bands off. These are split, designed to just snap in place right there. And these are usually pretty good. A lot of times you can reuse these, but if you're going in and replacing everything, it's not a bad idea just to replace it all. Even the piston seal doesn't look like it's bad, and it probably works, but best just go ahead and replace them so that all the seals are new at the same time, since these have been in there for many years. So I'm going to go ahead and just try to pry this guy out. Sometimes it's easier just to cut them, but sometimes you can just kind of pop them out of there. All right, so that's your actual seal right there, and then you have an O-ring in the bottom that it compresses against to seal the bottom of the groove. But it'll come as a seal like this whenever you buy these. You have the rubber expander and then the seal on top of that. So that's your piston. I don't particularly like these types of seals. I know that a lot of manufacturers like using them because you can get these in extremely high pressure, and they're double acting, so you don't have to have a lip seal on both sides. They're just a little more pain in the butt to get installed in there, and sometimes you got to have a little compression tool to squeeze around them, because when you put them on there you stretch them, and then when you get them on there they're kind of sticking out and they're a little hard to install. But it can be done. They're just a little more frustrating to work with. All right, so I'm going to go ahead and start sizing these things up. I'm going to do that off camera, and I'll bring you guys back and show you which part numbers. I'm going to be looking in my Hercules book. All the part numbers are the same, no matter if you're using Hercules or CRC or whoever that you're buying from. All the part numbers are the same. All right, so I need to measure the width of the grooves there for the wiper and the seal. I'm going to show you. I'm using my Starrett groove mic. So this is a Starrett number 260 groove micrometer. This is a super handy tool to have for doing applications like this right there, where a normal caliper is really difficult. You can't really get it into a small gland like this. So you have these two discs right here that you use to measure either the land, which is between the grooves, or the groove width there. So let's get in there and see how wide our groove is for the wiper. You just got to be real careful and get familiar with the feel and the touch. All right, so, and then, you know, it's a little rusty in there, but so what you have to do, whenever you're measuring the outside of the disc there, which is actually the inside groove width, whatever your measurement is here on the barrel, you have to add 50 thousandths to that. These two discs are ground to 25 thousandths wide. All right, so let's see what our measurement is, and you got to read it kind of opposite of what you usually read with a standard mic. You're going from the right to the left. So 100, 25, 35, 40. So 140 thousandths is what this is reading. You have to add 50 thousandths to that. So that's going to be 190 thousandths, right? So what that's telling me is that this groove is machined 3/16 wide, which is just a nominal standard size. And I'm pretty sure that's going to be the width for an ST style of wiper. All right. So I'll get in here after the video and remeasure it, make sure I got everything right, and write my measurements down. Let's go inside there to the groove, which is where our rod seal is going to go. These sometimes can be a little more tricky because they're on the back side. There's a big bevel machine on there to aid in getting the rod wiper popped into place. But I'm going to, let me just get a feel here because I don't think I have it yet. There we go. Now that's feeling pretty good. So that's feeling like, all right, that's measuring 300, let's just call it 375 thousandths. Add 50 thousandths to that, that's going to be 425 thousandths wide, which sounds about right. Those groove widths for the seals are usually, they're not like, they don't land on a standard size. They're usually wider so that you have room to stick the seal in there and get it to pop into place, and it gives it a little bit of room side to side. But anyway, just trying to show you guys a very helpful tool to do things like this. The Starrett number 260 groove mic. All right. So we measured the groove width. Now I need to know what the groove diameter is. And what I do, how I measure that is I use these spring calipers. Now these were modified by my dad or my granddad years ago. And this is what we've always used for getting those kind of internal groove diameters. And they've been modified to put more of a bend in the end of the caliper there. But what I was going to show you, so this is the one I always use, but you can get you some, you know, standard spring calipers from Starrett or whoever you like, and you just have to modify the bend in it so that you have a little bit more stick out on the legs there. And the reason I say that is because sometimes you get in here to measure these groove diameters with the standard bend that they put in them, it doesn't always reach that outer or the diameter in there. If you have a deep groove, sometimes it's actually hitting the bore of the workpiece there. So you just take you some, just get you some calipers and bend them out so that you have it to look more like this one right here, so you can reach those deep grooves. All right. So you get in here and measure this. I usually unwind it till the nut is loose right there, and then bring it back in until we just get that feel. And it's a reference measurement. It doesn't have to be exact. It's going to give you, and then what I do is just take calipers and just measure over the top of that and see what we're getting there. So I'm measuring 1 inch 885. So I'm going to call that 1 7/8 is what that groove diameter is there. All right. Do the same thing with the wiper. Do the same thing there. Verify it. Should be the same diameter. Yep. So it's a reference measurement, but you see that tells you what you need to know. So we're going to take that, turn it into a nominal size, whether it be imperial or metric. I'm going to call that 1 7/8, so we'll know what to look for in the book. Now we have our width and our groove diameter. All right, so I've gone through my hydraulic book. I've written down all of my part numbers that I need. We got our rod seal, rod wiper, the O-ring, the backup, piston seal, wear band, and then the O-ring for the tube and the O-ring for the piston there as well, the small O-ring. So what I want to show you guys, so I'm using my Hercules hydraulics book right here. This is an old one, 10 years old, but it's still valid because all the parts are the same. The only thing different is that they may be adding new stuff to these books over the years that I'm not aware of, but all these parts in here are like industry standard hydraulic parts, okay? So I'm in the inch seal, they also have metric. And what I do is once I have the diameters that I know I'm working with, whether it be your rod wiper, your rod seal, or even your piston diameter there as well. You take all that information, you write all those measurements down so then you can go into this book. Now, in this case, we didn't have a good seal to go off of, the rod seal, but it doesn't really matter. As long as you have your dimensions, you can go in here to these seals. You look at these pictures here and you try to find one that you know is going to work. Now, I'm going off of rod seals instead of piston seals, but this will get you going right here. We installed a lot of DRU style of rod seals over the years. So I started with the DRU. I went to that page, looked, well, they didn't have this one in the exact dimensions that I needed that I had written down for our gland. So I went up here to the RTU seal. This is another very common seal right there. Good for 5,000 PSI, speed 3 foot a second. But anyway, so that's another common that they have a lot of sizes in. So you go to that page, and I've got all these bookmarked here so we can get to it quickly. All right, this is your RTU isometric twin lip rod U seals. They have them in a lot of different sizes. So I've already written it down. We have an RTU 18-150-37. All this has to do with the sizing of that seal. So if we go right here, so I was looking for the ID being 1.5 inches because our rod is 1.5 inches. So that's your dimension you go off of, 1.5 inches right there. And nominal OD, our groove diameter, was 1 7/8. So 1.5 inches, 1 7/8. And then the height, the groove width that we measured, I said it was around 425 thousandths, right? Well, our groove width right there, it says 0.413 plus 10 minus 0. So that's the spec right there of our actual groove. So I wrote that part number down. Bam, there's our rod seal. And you just repeat that with the other things there as well. Is the rod wiper is an ST150. All right, that's a standard size for 1.5 inch rod. So our groove is machined to fit an ST150 rod. All right. When it comes to the O-rings, what I like to do, let me see if I can find it real quick. Where did I have it? So wear bands. All right, right here. O-ring gland dimensions. I use this page all the time to reference what size O-rings I need. O-rings are nominal IDOD, but your groove diameters are going to be different because you have compression on those. So they're not going to measure an exact nominal size. But what you need to remember is that you have basically 5 different series or thicknesses, cross section of O-rings. 0, 1, 2, 3, and 4. That's how I look. I look in this O-ring cross section. I go 0, 1, 2, 3, 4. So if I measure this O-ring right here, all right, just with the calipers, that's 209 thousandths right there. All right. Closest thing to that right here in the cross section is 210 thousandths. But I start the first one, that's a 0, 1, 2, 3. So this is a -300 series size O-ring. And then you just measure your nominal IDOD, and you look up in the chart right here to the -300s, and I have a -330, which is right here. Nominal size ID 2 1/8, 2.5 OD. All right, so that's our O-ring right there for our gland. The backup is going to be the same size as your O-ring, but there's a 575 or a 574 depending on what kind of backup, and this is the backup that I'm talking about right here. So we're just going to go with a urethane 575 backup, and the O-ring number is the same, matches it. Our piston seal is where we have a little bit of a difference here, okay? So on our piston seal, we're going to be going with a PS 1400 style glass fill PTFE piston seal. And I wrote on here, the groove diameter has to be modified to 2.108. And the reason why I put that is because our piston groove diameter does not match the exact specifications to any of the piston seals in this book. I checked all the two-piece seals. The PS 1400 is the closest one that I could find. And so we're gonna do a PS 1400-40, 2.5 OD. The width is about the same. Groove width's 129 thousandths. We might have to take 5 thousandths out of the width. And your groove diameter is 2.108, okay? Now when I measure with these calipers, you can see we're about 120, 119 thousandths. So that means we have just a little bit of this diameter that we need to machine to get this piston seal to fit in there. So that's what we're gonna do. And I'm doing that because none of the other piston seals in here match. They're just the wrong specifications. So there's absolutely nothing wrong with taking a piston or gland, if you cannot find the right size seals, and modify the width or the diameter of the grooves to fit a seal that you find for that. All right, so that's what we're gonna do with the piston. We've also got a wear ring and the tube O-ring, which is this small guy right here, and then the small piston O-ring right there. So that's those sizes written down there. So there's another little like crash course on how to find this information. If you guys will contact either Hercules or CRC Distribution, CRC is who I buy from. They're local to me. They're over in Robertsdale, Alabama. They have all the component parts. They have all the materials, including rod stock, tube stock, bearing bronze, ductile iron, all that stuff. And so I'm gonna get with them, get all of the seals ordered, get them coming, and then whenever they get here, you know, we'll get this stuff put together. But get you one of these catalogs so that you can take these cylinders apart yourself and you can see, you can do this just like anybody else. You just have to use your pictures here, find the seals you want, and go in there and just find the part numbers. And then you contact whatever hydraulic supplier you're gonna use, and you give them those part numbers right there, and they will match up to what you need, all right? So we'll bring you guys back when we're ready to start putting these cylinders back together.